Our next session is a very interesting one. It is door open detection. So before we go into the theory part and all your explanations, can you tell where and what applications you can use the detection of your doors opening or closing? Suppose you open the door and the lights go on automatically and the fans go on automatically. Then it will be interesting, isn't it? You can also use the same door open detection to make your security systems. How is that? When a door opens, we can consider that there is a thief coming in and you can make a buzzer go on. So many applications like this are therefore your door is detection. So we will combine your automation and security system. That is, when the door opens, your light should also glow and your buzzer should also buzz. For this, we need to first learn about the components that we are going to use. So the very interesting component here is your limit switch. It is also called in various other names such as bump sensor, snap switch, depending on the application that is going to be used. But this switch is a little different from the switches that we learned before. Can you notice that it has 3 terminals, whereas your other switches had 2 terminals only. But this has 3 terminals. Shall we see how the switch looks internally? Now this is the picture of it. I'll first tell you the parts and then I'll show you the working of it. So the top one is a metal flap. This is the one that is seen to us. And then this is your button. Next, using 3 terminals. So these parts are all seen outside, right? Now on the inside, it has a metal contact and a spring, just like your other switches. But this one will work a little differently. So under normal conditions, when you are not pressing, your first terminal will be connected to your last terminal. Now what will happen when you press? The button will go down, pushing the metal contact also. And now the first terminal is in contact with your second terminal. Now when you take off your hand, the switch will go back to the original position. So now we will call the first terminal as a common terminal. The third one as a normally closed. That is in normal conditions. This terminal is closed. And a second terminal as normally open. This is under normal conditions, it is open. So summarizing your limit, which has 3 terminals, common, NC that is normally closed and NO that is normally open. So in normal conditions, your common will be connected to NC. And when you press the metal flap, your common will get connected to NO. The technical name of the switch is SPDT switch, that is single pull double throw switch. Can you understand why it is called that way? It has a single pull, that is one arrow which keeps moving around, and double throw, that is it can move around 2 points. So it is single pull double throw switch. Now there are differences which are like this, that are even double pull double throw switches. So 2 things like this will be moving around inside. So now how can we use this to detect the opening and closing of your doors? You can place the switch in more than one way in a door frame to detect the opening and closing of your doors. You can place it either on the sides of the door and also either on the top or on the sides. Now when you open or close the door, the metal flap will get pressed and show you that the door is open. Shall we go into the practicals? Now take the limit switch from your kit. First, we shall see the parts that are there. So the first one is your switch, of course. So we already saw the picture of your switch. Can you see that there is a metal flap? Do not bend or break the metal flap. Be very careful. Next is your green color block. Can you see 3 holes there? So it has a common NC and NO. Can you spot all the 3? Now take your power supply board limit switch, LED board and your buzzer and mount all of them onto your project maker. Once you finish, we shall go into the connections. We shall do 2 tasks in this activity. Now our first task is to do a circuit which, when press the limit switch, your LED as well as the buzzer should be on. So for this, when you press the switch, what are the 2 terminals that are connected inside the switch? It is the common and normally opened, right? So now you have to use only these 2 terminals for this task. So the positive of your power supply board will be connected to the common. The normally open, that is NO, will be connected to the LED's positive. Now comes the next question. Where will you connect your buzzer? Will the positive of your buzzer go to the LED's negative, or will it go to the NO of the switch? Just like your LED. Now let's try the first one. Give the buzzer's positive to your LED's negative and buzzer's negative will go back to the power supply board's negative. So this is like a chain. I'll repeat it again. Your power supply, both positive will go to the common. The NO will go to the positive of your LED. The LED negative will be connected to the buzzer's positive. The buzzer's negative will come back to your power supply board's negative. Now, does this connection seem similar? We have learned this type of connection, right? It is series connection. Get LED and your buzzer are in series. Plus, one of device is connected to the minus of another device. Can you notice that? Once you have connected, give the battery and check your circuit. Press the switch that both the LED as well as a buzzer work. No, it didn't. Any one output device would have only worked. Either your LED would have glowed or your buzzer would have burst. Both of them will not work together or it would work very feebly. Am I right? Why is it so? Why didn't it work? This is because of the series connection. Remember, when you connected 2 LEDs in series, LED glowed very dull. So similarly, when you connect LED and a buzzer in series, the same problem occurs. That is low voltage that is coming to buzzer and that is not enough to make it buzz. So now what should we do? We should change the connection from series to parallel. Before we see how to do the correct connections, remove your battery and remove all the wires. Now let's make the correct connections. Now, first we should consider the LED alone. Let's forget about the buzzer. So what will you usually do? You will connect the plus of your power supply board to the common and then the normally open to the plus of your LED and the minus LED will go to the minus of your power supply board. So, your circuit does not complete with your LED. Now we will insert your buzzer, just like the LED. So the plus of your buzzer will go to the NO again. Now in this case, you are going to insert 2 wires in the same terminal. So in your green block, You can just, like that, insert two wires and screw it on the top. And then finally, you will connect the minus of your buzzer to the minus of your power supply board. So now this is your parallel connection. Your LED and your buzzer are in parallel. Once you have completed the connection, we shall check the output. Give the battery and check it. Now when you press the switch, did both your LED as well as your buzzer work? Yes, it will. So remember, when you connect more than one output device, always connect them in parallel. So the module diagram is similar to the connections we were seeing before. The plus of your power supply board will be connected to the common of your limit switch. The NO, that is normally open, is connected to the plus of your LED. The plus of the LED is again connected to the plus of your buzzer. And the minus if the LED is again connected to the minus of the buzzer. And the overall minus runs back to the power supply board's minus. Check if your answer is correct. Once done, we shall proceed to look into how to draw the circuit diagram. The circuit symbol of the limit switch is a little different. So there are three terminals in a limit switch. So now we draw all the three terminals and then an arrow that is pointing to one of the terminal. So when you pressed, it means that the arrow is going to the other terminal. So the first terminal is your common. The one that is connected it to is the NC, that is normally connected. And the other one is the NO, normally open. So now that you know the circuit symbol, try attempting your circuit diagram. Once you complete, we shall check the answer. Now the first step in your circuit diagram is to draw the circuit symbols. So first draw the circuit symbol of the limit switch that the devices that we are used are LED and your buzzer. And finally the battery. So we connected the plus of your battery to the common, your NO to the LED positive. The LED negative will run back to the battery's negative. Now we have to connect the buzzer in the same terminals as your LED. So your buzzer's positive will go to the NO of your limit switch and the buzzer is negative will go to the battery's negative. Check if your answer is correct. Once done, there is another task in the same experiment. So we shall see how to do it. The next task is very simple. Instead of making your LED and buzzer work, if the switch is pressed, now in this task, it has to work if the switch is open. That is, in normal condition itself, it should work. And when it is pressed, it should stop working. So there is only one simple change in connection. Can you guess what it is? The connection that was given in the normally open terminal of your limit switch should now be changed to the normally closed terminal of your limit switch. That is, which your wire is connected to NO in the previous task. Now take it out and connect it to NC. And then give a battery and check how your circuit is working. Now is your circuit working in the reverse way when the switch is open? Now both your LEDs as well as buzzer will be working. If you press the switch, it will stop working. So now this can be used in some conditions and the other task can be used in different applications. Now finish the module diagram and circuit diagram for the second task also. Once you have finished it, you should check whether it is correct. The module diagram is again similar to your connections. So the plus of your power supply board runs to the common of your limit switch. The normally closed will be given to the plus of LED. The plus of LED will again go to the plus of your buzzer Minus of your buzzer will run to the minus of your LED, and again minus of LED will run back to the power supply board minus. Check if it is correct or not. If so, we will go ahead and check a circuit diagram. The same rules apply again. Draw all the circuit symbols. The circuit symbol of the battery, the limit switch, LED and your buzzer. So the plus of your battery was given to the common, the NC was given to the plus of your LED, the minus of the LED will go to the minus of your battery, and the buzzer will again be connected to the same terminals as your LED. So the plus of your buzzer will be given to the NC of your limit switch. The minus of your buzzer will be given to the minus of your battery. Check if the answer is correct. Once done, go ahead and answer all your questions.